So let's now talk about how you actually write these square roots and cube roots and fourth roots. And it's using the radical symbol, at least this is one of the ways to write it. And this radical symbol right here, the way you say it is that is the nth root of a. So let's talk about how that actually works. So if n, which is called the index, is a positive even integer, and a is positive, for example, the square root of 25, then the nth root of a denotes the principal square root of a. So for example, the square root of 25 is equal to is equal to 5. The fourth root of 16 is equal to 2. So remember, there's 2 square roots of 25, there's 2 square roots of 16, but the radical symbol denotes the principal one, and that's the positive guy. Another thing to note here is that when the index is omitted, it's the square root. In other words, the default is that n is equal to 2. Okay, so scrolling down a little bit and moving on. So that's what happens when you have even roots. If n, which is the index, is a positive odd integer, and a is real, then the nth root of a denotes the nth root of a. Actually, to be really crazy about this, the real nth root of a, and we'll talk a little later about why that is so. So for example, the cube root of 27 is equal to 3. The cube root of negative 27, let me put that negative in there, negative 27 is equal to negative 3. And again, we have no ambiguity because these guys only have one real cube root, so we don't have to worry about anything like the principal square root or anything like that. Odd roots are much easier to handle than even roots. Let's take a look at the last thing, which is if n is any positive integer, and we've got the special case that a is 0, then the nth root of 0 is just 0. And it doesn't matter actually here whether or not n is positive or n is even or odd, because if you take the square root, it's always going to be, if you're taking the even root, then in theory there's a principal square root and the other guy, but in this instance the square root is unsigned, so there's actually only one of them. So that's the nice thing about 0. If you take the square root, it's 0. If you take the cube root, it's 0. It's just 0 no matter how you slice it. The last thing that I should mention at this point, which is note, if n is even and a is negative, so scrolling down a bit, so we've got if n is even and a is negative, so we're taking the square root or the fourth root of a negative number, the answer is not a real number. So for example, the square root of negative 25, the fourth root of negative 16, or any even root of any negative number, these guys are not real. Now don't try to say that they're empty set or do not exist or anything like that, because they actually do exist, they're just not on the real number line. And we're actually going to see later in section 7.6 what these guys actually do. But for the time being, we're going to wimp out and we're just going to stick with our story that they're not real. So let's just wrap this up by doing a little bit of evaluation. Now, I was planning on doing that in black. Let me just scroll down a little bit here. So let's evaluate the square root of 81. While we're at it, the fourth root of 81. How about the fourth root of negative 81? And the cube root of 125, and the cube root of 64. Okay, let's take a look at these guys. Square root of 81 is just 9. Again, 81 has two square roots, but the radical sign says give me the principal one. Now the fourth root of 81, you have to think what raised to the fourth power is 81, and that answer is 3. Again, 3 here is the principal fourth root of 81. This guy here is not a real number. The cube root of 125 is just 5. The cube root of 64 is just 4. Remember that 4 raised to the power of 3 is 64. And I'm going to scroll down a bit, and let's do one last one, which is the cube root of negative 64, and that guy is equal to negative 4. Remember, negative 4 all cubed equals negative 64, and it's totally allowed to take the cube root of a negative number. Just don't take the square root or the fourth root.